Now we want to work some problems that involve formulas, and we're going to use the same properties that we used in the previous section to solve linear equations in one variable. Here's our first formula. We want to solve for y, and the formula is 2x minus 6y plus 12 is equal to 0. I'm going to isolate the y on one side of the equation, so what I'll do is leave it right here and add negative 2x and negative 12 to both sides of this formula so that they'll be gone from this left side. When I do that, I'll have negative 6y is equal to negative 2x minus 12. That's adding negative 2x to both sides and negative 12 to both sides. Now I want to isolate y on the left side of the equation, so what I'll do is multiply by the reciprocal of negative 6, which is negative 1/6. If I do that to the left side, I do it to the right side also. Now negative 1/6 times negative 6y gives me y, and negative 1/6 times negative 2x will be positive 2/6x, which is 1/3 x, and then negative 1/6 times negative 12 is going to be positive 2. So there is my formula again. This time I've solved it for y. So y is equal to negative 1/3 x plus 2. This formula right here and my original one are equivalent. The difference is that this one has been solved for y. So y is written in terms of x in this formula. Here's our next one. Solve for v, and the formula is h equals v times t plus 16t squared. So what I'm going to do is add negative 16t squared to both sides, but before that I think what I'll do is reverse the two sides. So I have v times t plus 16t squared is equal to h, just so I can isolate my v on the left side of the equation. Now I'll add negative 16t squared to both sides. I get v times t is h minus 16t squared. Now I keep my eye on the variable I'm solving for, which is v, so I want to get rid of this t right here. I'll divide both sides by t or multiply both sides by 1 over t. Either way, I'll have v is equal to h minus 16t squared, all divided by t. So that is this formula right here solved for v. So when I solve this formula for v, I end up with this expression right here. Now you don't want to weaken and try to divide out these t's. You can't do that. As you'll see when we get to the chapter on rational expressions, there's a way to go about doing this division correctly. For right now, though, there's no dividing out those t's. Let's try one last example. I want to solve for x. Ax plus 4 is equal to bx plus 9. So I have two terms here that have x in them. Let's get them both over onto the left side of the equation and all the other terms onto the right side. So I'll add negative bx to both sides. I'll have ax minus bx, and then I'll add negative 4 to both sides. So on the right side I'm left with just 5. Now I want to isolate this x, so I'm going to have to use my distributive property in reverse and write this as a minus b times x is equal to 5. So combining these two similar terms, ax and bx, I combine them this way by taking that x outside. Notice by the distributive property, I can multiply these back out and I get ax minus bx. Now the coefficient of x is a minus b. Let's just divide both sides by it. And I end up with x is equal to 5 over a minus b. And that's how I solve that formula for x. So this is I have a little trick right here at the end where I have to use that distributive property to isolate the x, and I divide both sides by a minus b and get this expression.